Hi everyone, my name is Steve Flanders, and I'm here today to talk to you about Log Insight reference architectures, specifically for Log Insight version 3.0, the most recent GA version of Log Insight released last month. There are a few things I'll be pointing out here that do not apply to the older versions of Log Insight. I'll try to make note of that as we go through, but note that this is Log Insight 3.0 specific. First, some quick introductions. For those of you that don't know me, my name is Steve Flanders. I run Log Insight's customer-oriented R&D group. I serve as a subject matter expert on Log Insight. If you're interested in learning more about me or Log Insight, I'd encourage you to take a look at my Twitter at smflanders or my blog sflanders.net. So what is Log Insight? Well, Log Insight is a log aggregation tool. It provides correlation, analytics, alerting, reporting, dashboards, all sorts of interesting things to take your unstructured data and make them meaningful, to really provide insight. And this is a pretty good reference architecture diagram. It shows the Log Insight server, so it shows the scale up, scale out model, the load balancing that's available, the Log Insight agent, how you get data in. Syslog is very common. We also have our own ingestion API that is supported. And also how you query, which is primarily through the HTML5 web interface. Of course, all this is available through plain text and secure channels, depending on your use case. We can archive off. We can even selectively forward events out to different locations. Now, I only have 15 minutes to talk about this topic, and while Log Insight's a pretty simple and easy to use product, there are a lot of different pieces and a lot of different reference architectures possible. So I'm going to focus primarily on the server side today. So let's start with some basics, maybe defining a few terms. First, Log Insight could be standalone. It means it's a single instance, or it could be a cluster. And for Log Insight, a cluster means 3 or more nodes. A 2-node cluster is not supported today. It actually doesn't provide some of the benefits of clustering in general, which I'll touch on more. And with a cluster, you need to have a load balancer to get traffic in, balance it across, and also to query data out of the system. Now, it could be these 3 nodes, it could be more than 3 nodes, so I'm actually going to use a different icon here. It looks more like a cluster. And you're going to see this used throughout these different reference architectures that I present. The other key bit of information to know is how inputs happen into the system. And there's really 2 primary interfaces. You have to get ingestion in, which pretty commonly is syslog. A lot of devices support syslog, that's a known RFC. But we also have our own ingestion API, which provides significant benefits over the syslog RFC. The RFC has very strictly defined standards that you must follow. The ingestion API has more free-form, more metadata, more advanced functionality available to you. Now in terms of syslog, we have the standard TCP UDP port 514. We also support ESXi's TCP SSL, which is on 1514. In terms of the ingestion API, we have a plain text port on port 9000, and the SSL encrypted is through 9543. And then as I mentioned, the query interface, it's all based through HTML5. You can use 80 and 443, pretty standard ports. Now, basically this is broken down into web, syslog, and what we call CF API, or Common Framework API. Let's see how this actually works to the Log Insight server architecture. First, I could have a standalone instance. This is where a lot of people start when they're trying out Log Insight, or maybe they don't have high availability requirements, they have a low ingestion rate, and we basically point everything, the web, the syslog, the CF API, directly into the Log Insight instance. Now, in production environments, as you're scaling out the environment, if you need high availability, that's where clustering comes in. So how does that look? Well, first you're going to start with a standalone instance. Then you're going to deploy another instance and you're going to join it to the cluster. Now, when you do that, you have to actually load balance the traffic. You don't want to point directly to one of the nodes, because if that node goes down, you won't be able to ingest, you won't be able to query from that node. So Log Insight supports this notion of an integrated load balancer. You don't need a third-party load balancer to use clustering in Log Insight. From the administrative clustering page, you simply click a checkbox that says you'd like to use the integrated load balancer, you specify a virtual IP address or VIP, and you're good to go. Log Insight handles the rest for you. Now, basically you want to point everything to this integrated load balancer. So that means the web, the syslog, the ingestion API, that all comes into the integrated load balancer, and the integrated load balancer handles everything else for you. Basically, the integrated load balancer provides layer 4 load balancing, and the Log Insight nodes provide layer 7 or message-based load balancing. Now this makes it possible to ensure that traffic is equally distributed across the cluster,
and it also makes it possible to query from different interfaces. So we can actually build this out, but remember, even though you have to start with a 2-node cluster, we don't support 2-node clusters. So if you remember the picture, it has to be 3 nodes or more. So maybe it's 6 nodes. 3 is the minimum when you're clustering. If you only have 2, you actually don't have ingestion high availability or query high availability. So it's really critical that you have 3 or more. And now your queries are across the system. The cluster still has this notion of a master, the first node, and the workers, but really it's a master list or distributed architecture as part of LogInsight 3.0. Well, let's explain what that means. So let's say I lose one of the workers. It goes down for whatever reason. Well, ingestion still continues. Even if the VIP was running on that worker, it will fail over automatically to another node in the cluster, and ingestion will continue. Queries will also continue. Now, in the case of a worker, maybe the UI isn't served there, so maybe a better example would be the cluster master node goes down. It doesn't matter. Again, if the VIP is on that node, it will fail over, ingestion continues. Querying is still capable because all of the nodes can serve the UI, all of the nodes can issue queries, the results can be aggregated and displayed to the user. Now, it is important to note that the ingestion events are stored on a single node today. So if any node goes down, the events on that node are unavailable until the node comes back up. Now, LogInsight notifies you, hey, a node's down, you only have partial results, but that's just something important to keep in mind. All right, so how about more complex environments? What does really the environment architecture beyond the LogInsight server look like? Well, you could have a variety of different components in your environment. Remember, while it's called VMware vRealize LogInsight, and while it is best for VMware and for vSphere, it does way more than just VMware products. It works for VMware, non-VMware, physical, virtual, it doesn't matter. Linux, Windows, we have agents that are supported because Windows does not natively support the syslog protocol, but our LogInsight agent supports syslog and our own ingestion API. So really, you can point traffic to LogInsight as long as it's syslog or ingestion API. And while our agent leverages that ingestion API, it's an open RESTful API. You can code directly against it if you want to. You don't have to use the agent. Of course, the agent provides some benefits. It has compression. It has the ability of batching events. It has a dispatch queue. It can do keep bookmarking of where it left off. So if there's a disconnect between the client and the server, when the connection is restored, it can pick back up. Traditionally, for most syslog agents, you play by the rules of the protocol you're leveraging. In the case of UDP, the events are dropped if you can't connect. In the case of TCP, it'll retransmit, but the buffer and caches are only so large. Some of the more advanced agents might support memory caching. Most don't support, most free ones don't support a dispatch queue. The LogInsight agent supports all of this. So it really is a big value add for both Linux and Windows. Even though Linux has rsyslog, syslog, and G by default, again, they don't have some of the more advanced features like dispatch queues or the ability of sending compressed in the free versions. So in a greenfield environment, you could really point anything and everything to a LogInsight instance. Maybe that instance is standalone, or maybe it's a cluster. Now, why would you cluster? There's several reasons. One is you need to scale up your ingestion load. Like you've hit a configuration maximum, you need more nodes to sustain the load. But maybe you have business requirements of ingestion high availability or query high availability. It may not be a scale up requirement, it might be a high availability requirement. Again, clustering will solve this for you. Now, I do want to talk about not supported things as well, and I do apologize, this isn't my best PowerPoint picture here. What I'm trying to demonstrate is you have 3 different data centers, and you want to collect logs from all 3 of them. What some people often will try to do is to deploy a LogInsight cluster that's geo-distributed. Basically, I put a node in every single data center, but I want it to be one cluster so I have one query interface. This is actually not supported today. LogInsight nodes need to be in the same layer 2 network, and they have to be in the same data center. The layer 2 network requirement is for the integrated load balancer, and the same data center has to do with query performance and latency. So you should not try to deploy a cluster that's geo-distributed. Now, some of you may be wondering, well, I have multiple data centers, and I don't want to send syslog events over my WAN, so does LogInsight not support this? No, it definitely supports this. We call it forwarding or forwarders. You can deploy a LogInsight instance in every data center that aggregates the logs locally for that data center. So all the clients point to a LogInsight forwarder. That forwarder in turn is configured to forward events upstream to a central log insight server. Now your central log insight server has all the events, and at the same time fits the reference architecture of being in the same data center and in the same layer 2 network. Now, of course, if you need to scale up, if you need high availability, clustering is supported. You can do it in the primary location, the primary data center, or you can even do it down to the forwarding level. A forwarder is really just another log insight instance or another log insight cluster. The only difference is it's a separate cluster from your primary site. So the logs are separate between the two. This is the reference architecture for deploying across multiple data centers. And the benefit here is, if I'm actually aggregating my logs locally in a data center to a log insight instance, and I forward those events upstream, I don't have to use syslog anymore. I can use the ingestion API. That means compression. That means if it's disconnected, when I do reconnect, I can catch up where I left off. These are benefits that a syslog aggregator traditionally doesn't provide, but the log insight forwarder does. Now, what about DR? I care about disaster recovery. Like the log insight cluster could go down. Maybe the entire data center the log insight cluster's in goes down. Now what? Well, there's a few options available to you. One, if your clients support it, you can point them to 2 different log insight instances. Whether they're standalone or clustered, again, it doesn't really matter. But some clients still today only support a single remote destination. So what do you do in that case? Well, we can go back to our forwarding example. You can have your client send to a forwarder, and the forwarder actually supports multiple destinations. So maybe I have a central log insight cluster in my primary data center, and I have another central log insight instance in my DR data center, and the forwarder actually sends events to both of them. Now I don't need something like SRM to back up and recover. If I want to fail over, it's instantaneous because I've been receiving events in both data centers anyway. This is one way that you can achieve disaster recovery. Now, this is traditionally more of a greenfield. It could be a brownfield where you rip and replace your existing syslog solution, assuming you have one. And again, clustering works across the board. This can happen in both data centers. This can happen at the forwarder level. It's totally up to your business requirements of how many nodes you want to have and how you want to handle this. If you're in a true brownfield, go ahead and continue using your syslog aggregator, rsyslog, syslog-ng, whatever you have. Again, point it to multiple log insight instances in different data centers. That's fully supported. Or a single data center if that's what your business requirements are. If you want role-based access control, Log Insight handles that as well. You can send that all to a central Log Insight instance. And then we have the ability of defining data sets. So maybe just my application logs are seen by my app team, my storage logs by my storage team, or my security logs by my security team. And I don't want each other to see each other's logs. Finally, let's talk on some planning. So Log Insight's bundle as an OVA. It can be deployed standalone, and it can scale up. It has different sizing options, and it can scale out depending on your business requirements. We have a variety of different ingestion methods that I spoke about, and we have dependencies on core services like most products. NTP is important. DNS is important. We can archive to NFS and HDFS if you care about it, and we have deep integrations with vSphere and VROps because Log Insight is best for VMware products. The final thing, we have a sizing guide. It's in our official documentation, but we scale up dramatically. We're just north of 2.5 terabytes of logs a day in the Log Insight 3.0 cluster. We can easily support over 18,000 physical ESXi hosts in an environment. That's roughly equivalent to 100,000 virtual machines if you're collecting virtual machine logs. We have different sizing depending whether you can support 16 or 8 CPUs. The things to note are, networking is configured through OVF properties. Don't do it through the CLI. The virtual appliance is really a black box. And you need to enable SSH by default. It is disabled. OVF properties support this, or you can do it from the console. Finally, if you want to get sizing information, I have a blog post about it. I actually have a Google Sheet where you can plug in your variables and parameters and figure out how big of a cluster you need, how much storage, how much CPU. All the information is readily available in this Google Sheet. Take a look at my blog for more information. Thank you so much.